We are starting section 2.4, which is about continuity and one-sided limits. So we're going to start by looking at some graphs of some functions. So just bear with me, I'm going to sketch out a couple of graphs here. So we're only looking between x equals a and x equals b in these functions. And so the first picture we're going to look at is a function that has a hole in the middle So we're going to call this coordinate, this x coordinate here, c, where it has a hole there. So this is our first graph. I'll call this A. So our second graph that we're going to look at, A to B. Let's see, it looks like this. It's a piecewise function here. And then it has a picture that looks like that. So this is picture B, and then our final graph we're going to look at, again I'll say C is the point where it switches between the two, so C is there. Look at our final graph between x equals a and x equals b. My graph is going to look like this. And again, C is where I have this hole in my graph. So this is graph C. So all of these functions, I'll say they're not continuous at x equals C. So in all three, f is not continuous at x equals c. And in terms of a graph, the way you can think about continuous is if, when you're drawing out the graph, do you have to lift up your pencil from the paper? So in the first one, I'm drawing the graph, but then I have a hole in the middle, so I'd have to pick up my pencil and then put it back down to complete the picture. In the second one, I would be drawing the function, but then I'm going to have to jump down to complete the second part. So in all of these, they're not continuous. Now in this first one, we say that it has a removable discontinuity. And also in the third one, it has a removable discontinuity. But because those have just a hole in them, but if you look at the second picture, there's this big jump between the two pieces, and so this one is called a non-removable discontinuity. So let's define what it means to be continuous. We can see some examples that are not continuous, but let's define what it means to be continuous. So the definition of function f is continuous at c when three conditions are met. When these three conditions are met. So the first condition is that f of c is defined. So if you look, this first condition corresponds to that first picture. The problem is my function was not defined at x equals c. The second condition is that the limit as x goes to c exists. This was also a problem if you look in the second picture. when I approach from the left and when I approach from the right, at C, I had different values. So if I look here, they're approaching different numbers, and so the limit did not exist. And then the third condition is that these two things are equal. The limit equals f of c. And that was the issue in the third picture, is that the limit existed, but it was not the same as evaluating my function. So this is what it means to be continuous. And from here we can define a few more terms. I can say a function is continuous on an interval a to b, an open interval, when it is continuous at each point in the interval. And then another term that we're going to use is we're going to say a function that is continuous on the entire real number line from negative infinity to infinity is continuous everywhere.